students, in last video we have proved the property number 6 for the definite integration. Now in this video let us study about the property number 7 for the definite integration. The property is that integration f of x with respect to x, limits of integration minus a to a equal to 2 integration f of x dx, limits of integration 0 to a. Okay, if f of x is the even function and the value of this integration equal to 0 if f of x is an odd function. Okay students, so this is the last property of definite integration. The property is very important regarding to the board exam. The property may be asked for the 4 marks or sometimes for the 3 marks. Okay, let us prove the property and then we will solve the example from question number 3, exercise 4.2. Okay, so let us prove the LHS equal to integration, limits of integration a to a f of x with respect to x. Okay, and let us consider this is equal to minus a to 0 f of x with respect to x plus 0 to a f of x with respect to x. Okay, here by using property, that is integration f of x with respect to x, limits of integration a to b, this is equal to integration f of x with respect to x plus integration f of x with respect to x and limits of integration, that is a to b. We can write this a to c and c to b. Like this, by using this property we have written the LHS in terms of this, that is minus a to 0 and 0 to a f of x with respect to x. Okay, this is the last property. Okay, so LHS we can express in this way. Okay, and now this is equal to, suppose this is 1 and this one we can write this is equal to integration I1, this is integration I equal to I1, this is I1 plus 0 to a f of x with respect to x. Okay, now students, let us solve the first integration, that is here I1 equal to minus a to 0 f of x with respect to x. Okay, so put x equal to t. Okay, and differentiate with respect to x. With respect to x, we will get differentiation of x is 1 and this is equal to dt by dx. Okay, now put x equal to minus t. Differentiate with respect to x, 1 equal to minus dt by dx, and this implies dx equal to minus dt, okay, in this way. Hence the integration I1 equal to, and also change the limits of integration according to substitution. The lower limit is minus a, that is when x equal to minus a, then this implies minus a equal to minus t. This implies a equal to Okay, this implies t equal to a. That is when x equal to minus a, t equal to a. X equal to minus a, this implies t equal to a. Okay, and when upper limit is 0, when x equal to 0, this implies that x equal to, we put x equal to minus t, this implies 0 equal to minus t. That means when x equal to 0, t equal to 0. Okay, this is the upper limit. Now put all the substitution and the limits. We have the integration I equal to, when lower limit is minus a, t equal to a. So a to 0. Okay, f of the x equal to minus t and dx equal to minus dt. Now by using property that is integration a to b f of x with respect to x equal to b to a f of x dx, but after interchanging the upper limit and lower limit, the sign of integration changes, that is negative sign. Hence the integration, by using this property, integration I1 equal to 0 to a f of minus t. Okay, this minus dt, and by using this property, by interchanging the upper limit and lower limit, sign of integration changes into negative, and this negative sign negative becomes positive. That is 0 to a f of minus t with respect to t, and this is I1. This is I1. Okay, and hence our statement 1, that is, or integration I equal to I1 plus 0 to a f of x dx. So what is the value of I1? Put the value of I1, and this is the value of I1. So put this value, we will get I equal to I1. I1 is this. Okay, but see students, this f of t, again by using the property, that is integration 0 to a f of x dx equal to 0 to a f of t dt. Okay, so also we can write this I1 equal to 0 to a f of minus x with respect to x by using this property. Okay, now put the value of I1 in I. So here I equal to I1 is this, that is 0 to a f of minus x with respect to x plus I1 plus another, that is 0 to a f of x with respect to x, and this is 2. Okay, now consider the two cases, that is case 1. Case Case 1, that is if f of x is even function, then if f of x is even function, then what is the condition? Then f of minus x equal to plus f of x. If f of x is even function, then f of minus x equal to f of x. Okay, so if the function is even, then f of minus x is f of x. Then integration I equal to 0 to a, and this f of minus x is f of x with respect to x, because this is the even function. Okay, plus 0 to a f of x with respect to x. One time f of x with respect to x plus f of x with respect to x. This implies here integration I equal to 1 time plus 1 time, that is 2 times 0 to a f of x with respect to x. If f of x is even function. Okay, now consider the second case. Case second. What is the case second? The case second is that if f of x is odd function, then f of minus x equal to minus f of x, according to the odd function, definition of odd function. If f of x is odd function, then f of minus x is minus f of x, according to this definition. Okay, according to this definition, here the integration I equal to the statement 2 equal to integration I equal to integration I equal to 0 to a f of minus x is minus f of x, because this is odd function. According to the odd function, as f of x is odd function, therefore f of minus x is minus f of x by using this. Okay, and that's why f of minus x equal to minus f of x. Okay, 0 to a, and plus 0 to a f of x with respect to x, and this is equal to minus with respect to x, minus f of x with respect to x plus 0 to a f of x with respect to x. Positive negative that get cancelled, and this is equal to 0 if the function is odd, and hence we prove the property number 7. Okay, and this was the last property of this chapter. Okay, now let us solve the examples. The first example, or the example from exercise 4.2, we have solved the fourth problem. Now the fifth problem is that is 0 to 3. Evaluate the integration 0 to 3 x square 3 minus x raised to 5 by 2 with respect to x. Students, remember that In exercise 4.2 there are 3 questions. So in third question there are 15 problems, and all 15 problems we have to solve by the using the properties of integration. So here also we will solve by using the property of integration. Okay. So students, we have proved the property, that is 0 to a f of x with respect to x equal to 0 to a f of a minus x. In this way we can express. So if we express by using this property, then our integration I equal to, the integration I equal to, that is 0 to 3. So here a is 3 and this is x minus 3, a minus x, that is 3 minus x. Sorry, this is 3 minus x whole square into 3 minus, put the value of x is 3 minus x, okay, and raised to 5 by 2 with respect to x by using this property, okay, and this is 0 to 3, 3 minus x whole square is 9 minus 6x plus x square. These 3 get cancelled, minus minus becomes plus, and this is x raised to 5 by 2 with respect to x. Now multiply with x raised to 5 by 2, we will get 0 to 3, 9 x raised to 5 by 2 minus 6 x into x raised to 5 by 2 plus x square into x raised to 5 by 2 whole with respect to x. And now the integration I equal to 9 outside the integration, 0 to 3, this is x raised to 5 by 2 with respect to x, minus 6 outside the integration, x means x raised to 1 plus 5 by 2, that is 7 by 2, x raised to 7 by 2 with respect to x, okay. Now plus x square plus 5 by 2 means x raised to 9 by 2, x raised to 9 by 2, x raised to 9 by 2 with respect to x. For all the terms we use the integration formula x raised to n with respect to x, okay, and this is equal to integration I equal to 9 as it is, x raised to 5 by 2 plus 1 means x raised to 7 by 2 upon 7 by 2 minus 6 into x raised to 9 by 2 upon 9 by 2 plus x raised to 11 by 2 upon 11 by 2, okay. In this way we have to solve the problem, okay. Now so this integration I equal to this 2 to 2 multiply here, common out 2, and this is 9 by, see here limits of integration 0 to 3 everywhere, and limits of integration 0 to 3, okay. So we have taken the 2 outside, that is common out 2, and this is 9 by 7, 3 raised to 7 by 2, okay, minus 6 by 9 means 2 by 3, 3 raised to 9 by 2 plus 3 raised to 11 by 2 into 1 by 11, okay, and minus 2 into, put the value of x equal to 0, that is 0 minus 0 plus 0, that will be 0, upper limit minus lower limit. Now let us calculate. The calculation is 2 into, so students, so common out 3 raised to 7 by 2, that will get easy. 3 raised to 7 by 2. Then 3 raised to 7 by 2 only 9 by 7 will be there, minus 2 by 3 as it is. So we have common out 7 by 2, and there will be so here we have common out 7 by 2, that is 9 by 2 minus 7 by 2 means here remaining 3 raised to 2 by 2. Okay, plus 1 by 11 as it is, we have common out 7 by 2, and this is 3 raised to 4 by 2 will be remaining. And this is integration I equal to 2 into 3 raised to 7 by 2, 9 by 7 minus 2 by 3, 3 raised to 2 by 2 means 3 raised to 1 into 3. Okay, and now plus 1 by 11, 3 raised to 2 is 9, that is 9 by 11. Okay, and now these 3 get cancelled. Okay, this is equal to 2 into 3 raised to 7 by 2. The LCM will be 77, and this is, that is, the LCM will be 77, that is 99. We have to multiply here by 11, here with 77, and here with 9. Okay, and that is 77 into 2, that is 2 4s are 2 7s are 14, 2 7s are 14 plus 1 15, and plus 9 into 9, that is 81. Okay, sorry, 9 into 7, and that is 63, and integration equal to 2 into 3 raised to 7 by 2, 99 plus 63, and that is 162 minus 154, and that is 8 by 77, and hence integration I equal to 2 into 8 equal to 16 by 77 into 3 raised to 7 by 2. Okay, this is the integration I, and that is the solution of integration 0 to 3 x square into 3 minus x raised to 5 by 2 with respect to x. Okay students, in this way we have to solve. There the calculations are what? Okay, otherwise the problem is very easy. Now let us take another example. Another example is that evaluate integration minus 3 to 3 x cube upon 9 minus x square with respect to x. Okay students, so just we have studied the property. Which property? That is, see here, that is limits of integration minus 3 to 3. The problem is similar to this property. Integration limits of integration minus a to a f of x, and this is equal to, with respect to x, this is equal to 0 to a f of x, where the function is for even function. Just we have proved the property, and the value is 0 for odd function. Okay students, so let us check the function is even or odd. The function is that is f of x equal to x cube upon 9 minus x square. Let us consider the function. Now let us find out f of minus x. F of minus x equal to, that is, put the value of x equal to minus x. That is minus x raised to 3 upon 9 minus x square, and this is minus x raised to 3 upon 9 minus x square. If we check student, this is f of x. This is f of x with negative sign. Means here this is f of x and this is f of minus x. From 1 and 2 here f of x equal to f of minus x. Here f of x equal to this. We have find out f of minus x, and f of minus x equal to minus f of x. Okay, and hence the function is odd. The function is odd. And students, remember that if the function is odd, in that case there is not necessary to solve the problem. Directly the value of integration equal to 0. As here f of minus x equal to minus f of x from 1 and 2. And therefore the integration minus 3 to 3 x cube 9 minus x square with respect to x equal to 0. It is not necessary to solve the problem in case of odd function. But in case of even function, we have to solve the problem. Okay, and the function is odd, so don't solve the problem directly, its value is 0. Only check the even function or odd function, that you have to check only. Okay, and hence the integration of this equal to 0 because we have checked and the function is odd function. Okay, now let us take another example. Another example is that evaluate integration of minus pi by 2 to plus pi by 2 log of 2 plus sin x upon 2 minus sin x with respect to x. See student, this is similar to the property, that is limit of integration minus a to a. F of x with respect to x equal to 2 into integration 0 to a f of x if the function is even. If the function is even function. And this is equal to 0 if the function is odd. Because limits of integration minus a to a, and this is similar to given problem. Okay, that's why by using this property. But before going to solve the problem, students, first let us check that the function is even function or it is odd. Okay, now let us consider the function f of x equal to log of 2 plus sin x upon 2 minus sin x. Okay, this is the function. Now let us find out f of minus x. F of minus x is log of 2 plus sin of minus x upon 2 minus sin of minus x. So students, you know the formula, that is sin of minus theta equal to minus sin theta. By using this formula, we have this is equal to log of 2 sin of minus x is minus sin x, and 2 minus sin of minus x is minus sin x. Okay, and this is log of 2 minus sin x upon minus plus 2 plus sin x, and this is f of minus x. Okay students, and now see here, this is log of 2 minus, this is the log 2 minus sin x upon 2 plus sin x. This is f of minus x. Okay, and now this is equals to log of 2 plus sin x upon 2 minus sin x raised to minus 1. This is equal to log of 2 minus sin x, 2 plus sin x raised to minus 1. How? This is equal to, by using log of m raised to n formula, this is minus log of 2 plus sin x upon 2 minus sin x. This is equal. How it comes? See students, f of x equal to this. F of minus x, by using this formula, we have this. And this is log of 2 minus sin x upon 2 plus sin x. Means, if we changes here, we can write here, that is log of 2 plus sin x raised to minus 1 log of m raised to n minus log of 2 plus sin x 2 minus sin x. This value equal to. And according to our function, that is here f of minus x equal to minus f of x, because log of 2 plus sin x upon 2 minus sin x equal to minus log of 2 plus sin x upon 2 minus sin x. Hence the function is odd. And therefore its value not necessary to calculate the value. Its value is that is integration minus pi by 2 to plus pi by 2 log of 2 plus sin x upon 2 minus sin x with respect to x, and this value equal to 0 according to the odd function. As the function is odd, that is not necessary to calculate the value, and hence the integration, its value is equal to 0 because the function is odd function. Okay students, so we will continue the remaining problem in next video.